So let's start with task number 1. I'll name my list persons. It's a normal list and it contains dictionaries. And each dictionary has a name. I'll use Max and age. I'll use my age, 29, and hobbies. And hobbies, again, is just a list. And here I'll have sports and cooking, let's say. And since this will become rather long, I'll split this over multiple lines. Thankfully, we can do that in Python like that. So we can simply split it after the commas and after the brackets. So now this is my first person here. Now I'll add a second person, Anna, 28. Hobbies are dancing. And that's it, let's say. I don't want to type that much. And the third person, Manu, he's 33, let's say. And we add eating here. So this is my list of persons. Now let's use that list of persons in task number 2. We should use a list comprehension to convert this list of persons into a list of the names of the persons. So person names is the variable where I want to store that new list. And for that, I'll get my person, so person for person in persons with an S at the end. That's my list of dictionaries. That is a single dictionary. And here I simply access the name to, well, get that name. Let's print persons. And let's also, of course, print person names to see if that worked. I'll execute the assignment file here. And I get, first of all, my list of the complete persons, and then a list of just the names. So task number 2 is already solved. Now let's move on to task number 3. Let's use a list comprehension to check whether all persons are older than 20. For that, are older is a new variable I'll create. And I'll use a list comprehension because, well, I'm prompted to do so. Otherwise, you could, of course, also use a for loop, for example. And there, I'll again go through all my persons in my persons list. And here I want to check if person age is greater than 20, because I should check if they're older than 20. Now, if I do that and I print are older, what I get here is true, true, true. Now you learned that there's a helpful method, all, which I can wrap around a list to check whether all values in that list are true. Any would return true if any value is true, all does so if they all are true. So now our older will no longer store a list of true or false, but just one single value, true or false. So if I execute my file again, I just get true. And if I briefly change my age to 19 and I re-execute this, I'd get false, of course. So I'll switch this back to 29, and we can already move on to task number 4. Copy the person list such that you can safely edit the name of the first person without changing the original list. We learned about that reference versus value thing, and that is exactly what matters here. So I'll create a copied persons variable, and just doing this, so just assigning persons, would not do the trick. It would not copy that list of persons. Instead, we use the range operator, like this. And now if I added copied persons, the first person, and I change its name to, let's say, Maximilian, my full name. If I now print copied persons, and I run this file, we see that for the new persons, my name was changed to Maximilian. So we're done, right? Well, we should check if the original persons array is unchanged, because that is part of the requirement. The original list must not be changed. So let's print out persons2, and let's clear this and run the assignment file again. And we can see the first output here is coming from the copied persons, but the second is coming from persons, and their name also was changed. Because as I explained to you, we did copy the list, and we do have a new list here, but it's a shallow copy only. The complex data structures, the iterables inside of that list, were not copied. It's not a deep clone. So if you want to ensure that my persons in there, the dictionaries, are cloned, this approach won't do the trick. So I'll comment it out. Instead, copied persons can be achieved by using a list comprehension. Of course, you could have also used a for loop. There are multiple ways of achieving this. And here I'll go through my persons. So person for person in persons. We did this 2 times before. Here, this is my dictionary. And now I can call copy to create a copy of that dictionary. And a list comprehension gives me a new list anyways. So now we're copying both the list and the dictionary in the list. So now if I save this and if I clear and I re-execute my assignment file, you see the copied output has the new name, whilst the original list has the old name, because I did copy the dictionary with the copy method. And that is task number 4 solved. Now, task number 5 isn't too hard, just a little practice so that you don't forget how unpacking works. You should unpack the persons of the original list into different variables and output these variables. So here I'll have P1 for person 1 from my original persons array, and unpacking is not this, so we could of course do that. We could do P1, P2, P3, and access person 1, 2, 3, and then simply print P1, print P2, and print P3. But if we do that, we're using indexing, not unpacking. So whilst this does work, we're outputting these persons, we're failing to complete that task. So instead, what we should do is we should say P1, P2, P3, all assigned to just persons, and it will automatically pull the persons out of there. So now if I repeat this, we get the same output as before, but now we are using unpacking. And this is this assignment solved.